But even within humans, you see a spectrum where some people are relatively dumber and they'll perform work on IQ-like tests. Doesn't that just suggest that as you have bigger and bigger models, they can pick up bigger and bigger pathways or more general ways of reasoning?
Absolutely.
But then isn't that intelligence?
No, it's not.
Suppose there's a programmer at Google. They go into the office in the morning. At what point are they doing something that 100% cannot be due to fetching a template that could even if they suppose they were an LLM? Still not sure. I mean, I know how to. I studied computer science. Like, if I had become a code monkey out of college, like, what would I be doing? I go to my job.
So if you look at the way LLMs work, they're basically this big interpolative memory. And the way you scale up their capabilities is by trying to cram as much knowledge and patterns as possible into them.
To the extent that they do have so much in distribution, to the extent that we have trouble distinguishing whether an example is in distribution or not. Well, if they have everything in distribution, then they can do everything that we can do. Maybe it's not in distribution for us. Why is it so crucial that it has to be out of distribution for them? Why can't we just leverage the fact that they do get to see everything?
Right. You're asking basically what's the difference between actual intelligence, which is the ability to adapt to things you've not been prepared for, and pure memorization, like reciting what you've seen before. And it's not just some semantic difference. The big difference is that you can never pre-train on everything that you might see at test time, right? Because the world changes all the time. So it's not just the fact that the space of possible tasks is infinite. And even if you're trained on millions of them, you've only seen 0% of the total space. It's also the fact that the world is changing every day, right? This is why the human species, has developed intelligence in the first place. And well, if our environment was static enough, predictable enough, what would have happened is that evolution would have found the perfect behavioral program, a hard-coded static behavioral program, would have written it into our genes. We would have a hard-coded brain connectome, and that's what we will be running on. But no, that's not what happened. Instead, we have general intelligence. So we are born with extremely little knowledge about the world, but we are born with the ability to learn very efficiently and to adapt in the face of things that we've never seen before. And that's what makes us unique. And that's what is really, really challenging to recreate in machines.
But even within humans, you see a spectrum where some people are relatively dumber and they'll perform work on IQ-like tests. For example, Raman's progressive matrices. If you look at how the average person performs on that, and you look at the kind of questions that is a sort of hit or miss, half of people will get it right, half of people will get it wrong. Some of them are like pretty trivial. For us, we might think like this is kind of trivial. And so humans have AGI, but from relatively small tweaks, you can go from somebody who misses these kinds of basic IQ test questions to somebody who gets them all right, which suggests that actually, if these models are doing natively, we'll talk about some of the previous performances that people have tried with these models, but somebody with a Jack Cole with a 240 million parameter model got 35%. Doesn't that suggest that they're on this spectrum that clearly exists within humans and they're going to saturate it pretty soon?
So they're basically these big interpolative databases, interpolative memories. And of course, if you scale up the size of your database and you cram into it more knowledge, more patterns, and so on, you are going to be increasing its performance as measured by a memorization benchmark. That's kind of obvious. But as you're doing it, you are not increasing the intelligence of the system one bit. You are increasing the skill of the system. You are increasing its usefulness, its scope of applicability, but not its intelligence, because skill is not intelligence. And that's the fundamental confusion that people run into, is that they're confusing skill and intelligence.
So, okay, let's look at one of the benchmarks here. There's one benchmark that does grade school math, and these are problems that like a smart high schooler would be able to solve. It's called GSM 8K, and these models get 95% on these. Like basically,
sure,
they always nail
That's
it.
memorization benchmark.
Okay, let's talk about what that means. So here's one question from that benchmark. Now, when you say memorization, it still has to reason through how to think about fractions and what is the context of the whole problem, and then combining the different calculations it's doing.
It depends how you want to define reasoning. But there are two definitions you can use. So one is, I have available a set of program templates. It's like the structure of the puzzle. which can also generate its solution. And I'm just going to identify the right template, which is in my memory. I'm going to input the new values into the template, run the program, get the solution. And you could say this is reasoning. And I say, yeah, sure, okay. But another definition you can use is reasoning is the ability to, when you're faced with a puzzle, given that you don't have already a program in memory to solve it, you must synthesize on the fly a new program based on bits of pieces of existing programs that you have. You have to do on-the-fly program synthesis. And it's actually dramatically harder than just fetching the right memorized program and reapplying it.
Well, bigger models can pick up these kinds of circuits, which smaller models apparently don't do a good job of doing this, even if you were to train them on this kind of data. Doesn't that just suggest that as you have bigger and bigger models, they can pick up bigger and bigger pathways or more general ways of reasoning?
Absolutely.
But then isn't that intelligence?
No, it's not. If you scale up your database and you keep adding to it more knowledge, more program templates, then sure, it becomes more and more skillful. You can apply it to more and more tasks. But general intelligence is not task-specific skill scaled up to many skills. Because there is an infinite space of possible skills. General intelligence is the ability to approach any problem, any skill, and very quickly master it using very little data.
So my claim is that by doing this pre-training on bigger and bigger models, you are gaining that capacity to then generalize very efficiently. Let me give you an example.
I think in practice, that's a very complex algorithm, right? But it comes up quite a bit on the internet. So they've basically memorized it. And what's really interesting is that they can do it for a transposition length of like 3 or 5, because they are very, very common numbers in examples provided on the internet. But if you try to do it with an arbitrary number like 9, it's going to fail, because it does not encode the generalized form of the algorithm, but only specific cases. It has memorized specific cases of the algorithm, right? This is exactly what enables you to navigate every new day in your life.
I'm forgetting the details, but there was some study that chess grandmasters will perform very well within the context of the moves that...
Excellent example, because chess at the highest level is all about memorization. Chess is a memorization game.
Okay, sure. We can leave that aside. What is your explanation? Suppose there's a programmer at Google. They go into the office in the morning. At what point are they doing something that 100% cannot be due to fetching some template that could, even if they, suppose they were an LLM, they could not do if they had fetched some template from their program? Like at what point do they have to use this so-called extreme generalization capability?
Forget about Google software developers. Every human, every day of their lives is full of novel things that they've not been prepared for. You cannot navigate your life based on memorization alone.
Suppose you just stepped out of remote work with an LLM and they're a programmer. What is the first point at which you realize this is not a human, this is an LLM?
What about I just send them an arc puzzle and see how they do?
No, like part of their job, you know?
But you have to deal with novelty all the time. The essence of programming is engineering mental models, like mental representations of the problem you're trying to solve.
But you can, we have many people can interact with these systems themselves, and you can go to ChatGPT and say, here's a specification of the kind of program I want. They'll build it for you.
As long as there are many examples of this program on like GitHub and Stack Overflow and so on, sure, they will fetch the program for you from their memory.
But you can change arbitrary details. You
no,
can
it doesn't
say,
work.
I needed to work on this different kind of server.
If that were true, there would be no software engineers today.
But it seems like they're on this kind of smooth spectrum that we see even within humans, where some humans would have a hard time doing an ARC type test. We see that based on their performance on progressive Raven's matrices type IQ tests.
I'm not a fan of IQ tests because for the most part, you can train on IQ tests and get better at them. So they're very much memorization based.
Still not sure. I mean, I know how to, I studied computer science. Like, if I had become a code monkey out of college, like what would I be doing? I go to my job. What is the first thing my boss tells me something to do? When does he realize I'm an LLM? If I was an LLM?
Probably on the first day, you know.
If you can do this for every single thing that supposedly requires intelligence, then what good is intelligence? Apparently you can just brute force intelligence.
If the world, if your life were a static distribution, then sure, you could just brute force the space of possible behaviors.
if you're like, your kid learns to do algebra and then like now learns to do calculus, you wouldn't say they've memorized calculus. If they can just solve any arbitrary algebraic problem, you wouldn't say like they've memorized algebra. They'd say they've learned algebra.
Humans are never really doing pure memorization or pure reasoning.
But that's only because you're semantically labeling when the human does the skill, it's a memorization. When the exact same skill is done by the LLM, as you can measure by these benchmarks, and you can just like plug in any sort of math problem.
Sometimes humans are doing the exact same as the LLM is doing, which is just, for instance, I don't know, if you learn to add numbers, you're memorizing an algorithm, you're memorizing a program, and then you can reapply it. You are not synthesizing on the fly the addition program.
So obviously at some point, some human had to figure out how to do addition, but like
yes.
the way a kid learns it.
So we can automate more and more things. And yes, this is economically valuable. And yes, potentially there are many jobs you could automate a way like this, and that would be economically valuable. But you're still not going to have intelligence. So you can ask, okay, so what does it matter if we can generate all this economic value? Maybe you don't need intelligence after all. Well, you need intelligence the moment you have to deal with change, with novelty, with uncertainty.